Hello everyone, my name is Abhinav and I am working as a BMS algorithm development engineer at Decibels Lab. In this video, we will see what are all the potential replacements for existing lithium-ion type chemistries for EV applications. So in this video, we will see three types of potential chemistries that can act as replacements to lithium-ion type cells. So starting with sodium-ion cells, and then we'll go to aluminum A cells, and then we also explore lithium sulfur cells. So for the first one, that is sodium ion cell, we can see that it is having a much lower cost per kilowatt hour compared to that of lithium ion type cell, making it a very promising replacement in the upcoming few years. However, its gravimetric energy density is not as high as lithium ion cells currently because the type of electrolyte and the type of electrode materials that it has does not allow it to exhibit much more higher energy storage capability like that of lithium ion cell. So, with some future research and some more chemical additives and some changes in chemical compositions, the existing gravimetric energy can be brought up to more than 200 watt-hours per kg. However, in terms of thermal safety, sodium-ion cells are much more reliable and much more safe compared to that of lithium-ion cells, once again because of the material used as electrolyte. So, the electrolyte is not as potent and not as dangerous as that of lithium-ion cell, and instead uses a much more stable type of electrolyte. The battery material is very commonly available, once again making it a much more affordable alternative to that of lithium-ion cells. And also its cycle life seems to be very promising of almost 4,000 cycles as of today's research. And of course, in the upcoming few years, with some additional research and such changes in internal properties, it can be increased even more and can be brought up to almost 5,000 to up to 6,000 cycles. So nominal voltage will definitely be low as of now because of the lower energy available per unit cell. Compared to lithium ion, it is currently around 2.6 volts. So next, coming to aluminum air type cell. Aluminum air type cell is one of the most promising replacements for lithium ion cells because of the fact that its gravimetric energy density is almost 5 to 6 times as high as lithium-ion cells, along with the fact that its cost per kilowatt hour is very low. The reason is because the existing material inside the aluminum air type cell does not require a solid cathode and requires only an anode to be present that is made out of pure aluminum. So instead of having a material of some type, suppose for example some compound of magnesium or some compound like manganese or cobalt as cathode, instead there is direct air being used as cathode. So this enables the cell to be not only cheaper but also much lighter and having a much higher energy per unit mass. So that being said, we also have a much lower thermal runaway risk or basically thermal safety risk in this type of cell compared to lithium-ion cell. So battery material is very commonly available in the Earth's crust since aluminum is very abundantly available, again compared to lithium-ion cells, as lithium-ion cells will require lot of processing and a lot of excavating from the earth. So cycle life, however, there is a major drawback here because these type of cells are not rechargeable or reusable. They have to be discarded once the complete potential within the cell has been used up. So why we know that lithium-ion cells can be recharged and recycled multiple times. So with some future development, it can be promised that cycle life can be improved and these cells can definitely be reused. Also, another drawback is that per cell, there is much lesser energy available. So therefore, nominal voltage comes down to 1.2 volts because the chemical potential reduces. So again, with some future development, some extra chemicals additives can be added and the complete overall performance can be improved and the nominal voltage of the cell can also be brought. So coming to the next one of the other most promising ones is lithium sulfur type cells. So in this lithium sulfur type cells is also having a pretty good gravimetric energy, so up to almost 600 watt-hours per kg, which is almost 2 to 3 times that of lithium-ion cells. Also, its cost per kilowatt hour once again reduces to almost half of that of lithium-ion cells, making it a much more affordable alternative with a very low thermal safety risk, very low, and also having very commonly available battery materials. So we know that sulfur also is one of the most commonly or abundantly available materials in the Earth's crust. However, it is currently said to have very low cycle life because of some chemical properties of sulfur compounds. Basically, when it is mixed with lithium, the available chemical energy goes on decreasing as and when the cell is used more and more. Therefore, the cycle life is currently low. So currently research work is being done to improve the cycle life from about 100 cycles to more than at least 500 to 600 cycles by changing the properties of lithium sulfur compounds. Also, the nominal voltage, which is nothing but the total chemical potential within the cell, is again low, simply because of the fact that lithium sulfur compounds are having much lower chemical potential compared to that of lithium ion cells. So to summarize, in this video, we have seen what are all the different possible chemical replacements for lithium ion type chemistry cells, namely lithium sulfur, aluminium air, and sodium ion batteries. So with some more future further development and some future research work, definitely some more improvements to these existing chemistries can be made and can potentially serve as replacement of lithium ion type cells. So thank you for attending this video. I hope that this video was useful.